Oh, where the dot is, this way. So like this.
That's better. Hi, Cranston.
Good afternoon, Jay. How's it going? We're sorted.
Well, you're with hydrogen car carriers?
No, I'm with a company called Select Engineering Services. We do a lot of hydrogen contract, consulting type work.
Okay, software.
And the hardware.
Yeah?
Yeah, we play around and,
Okay.
remove and replace components, that sort of thing.
Okay, Cranston Polson. Let me just check the sound because I'm always nervous about the sound. And, okay, I got some loads of sound.
Excellent, that's good.
So Cranston, you do hydrogen cars.
Right, yeah, we support some of the DOD's hydrogen vehicles on the island, and yeah,
You say the island, this island?
this island on the island.
How many hydrogen cars are on this island?
There's 16 fuel cell vehicles. And
Oh,
then
I want to talk to you about that. May I talk to you about that?
you can, yes.
Who owns the 16?
They're actually owned by GM. There's another 10 Ford Escapes, they're internal combustion, but the 16 fuel cell vehicles are leased to the DOD, 6 to the Navy, including the Marines, and then 5 to the Army and 5 to the Air Force.
Sounds like somebody's convinced the Pentagon this is the way to go.
That's a big question that you didn't.
Okay, well, you don't have to answer that.
Oh, I won't then.
But if you did
Right.
answer it, you probably have to agree with me.
Well, yeah, there's a lot of the manufacturers putting a lot of money into it. All of the manufacturers
Mostly GM.
are. No, globally, BMW, Vauxhall, Renault, Nissan, Toyota, the
Yeah.
full spectrum.
Yeah.
They're all investing in.
How did you get into this business?
That's interesting. I arrived in Vancouver back in 2006 and discovered there was an industry based on hydrogen.
Really?
And
Like a
then
car
I
industry
bashed
based on
the door
hydrogen
down.
or an industry based on hydrogen?
An industry, there was an integrated waste hydrogen utilisation project that had $16 million from the government. They were capturing waste hydrogen from a chloroalkali plant and putting it in some vehicles. So, yeah, I
How
just
long
kept
ago was
knocking on
that?
the door. That was 2006.
And your training was in engineering?
Mechanical originally.
Mechanical engineering.
Yeah.
So, but if you had to go back and prepare yourself in a more proper fashion, what would you study?
I suppose chemistry, science, but there is a lot of mechanical. There's a lot of software. It's mechatronics nowadays. All plants, all systems are mechatronics.
Everything. Yeah.
But yeah, there's a lot. It depends if you want to go into the R&D or you want to be part of, the commercialisation part of it.
What part are you?
I'm sort of in the middle. A little bit on both sides. I've done a lot of R&D, developed fuel cells and that sort of thing. But now on the other end, trying to, take it out to the public. Yeah, commercialise it. Yeah.
Well, this is really very important, Cranston. I'll tell you why. It's because transportation is the one element of potential energy, success that is not successful. Sorry. I mean, you can tell me 16 cars, and you can also tell me that that I could buy a car. I could buy a hydrogen car. The problem is that I can't buy a hydrogen car. If you did tell me I could buy a hydrogen car, I would probably buy one because I think it's the way to the future. What do you think?
I agree with you. You can lease one in California. I think
there, right?
Yeah, $670 a month or something for.
And what kind of feedback are people giving about it?
That's pretty secretive, but I think quite good. Everybody that drives fuel cell cars say they're the same as a normal road car. You don't know any difference. It's a lot quieter.
Yeah.
That's about it.
Well, let's look at the macro first, though. So the thing about hydrogen is that you can get it. I mean, I hope you can get it. Most places, I think you can get it. And if you couldn't get it, you could in the short term, in the near term, you could get it. And it can be moved. It can be moved.
Can be
It's
transported.
easier to move actually than easier to move than electrical batteries, I think.
Sure. Lightning's,
Yeah,
yeah,
yeah.
yeah.
So, and then of course it's good for the environment, or better for the environment. You can use hydrogen for so many things, but especially including transportation. So I'm thinking that it's actually a better bet than the electric car. That's what I'm thinking. What are you thinking?
I think they're complementary technologies.
Oh, why are they complementary?
All hydrogen fuel cell vehicles have a battery pack. All the electricity generated goes through the buffer of a battery.
Yeah.
So the better the batteries get, the better the fuel cells get. They
So
go
you're
together.
happy to see them succeed?
Look, they will, yes, of course. Any advancement in the battery industry is an advancement for us. You will never be able to get a battery to charge in 10 minutes. That's my personal view.
That's the
and
difference.
the range,
That's the difference.
the weight and the range, the energy density. You will not be able to get a battery car to go for 500 miles.
Can you get a hydrogen car to do that?
Yes.
Wouldn't the whole
Probably
tank?
not quite that
But
far.
the tank have to be pretty big.
No, you just go high pressure. They're going to 10,000 psi now, so 700 bar. So 4 tanks, sort of that round and that long, will get you 4 kilograms in the Equinoxes here, and that's about 200 miles or more, depends how you drive. But I believe, Hyundai maybe in Scandinavia have got up to 350 miles. They may have even pushed that now in the smaller cars at 700 bar.
Okay, so I mean, it's very appealing that you don't have range anxiety because you can carry enough to get you around.
Right, and 3-minute fuel.
And 3-minute fuel, big thing. Big thing.
You don't have to charge it up overnight, that sort of thing, and you should have hydrogen available at fuel stations.
So you say they complement each other. I mean, you're not suggesting, are you, Cranston, that we need to have those charging stations everywhere, and then also hydrogen stations also? I mean, side by side, wouldn't that be slightly less than efficient?
The charge points that
Well, they're expensive. They're expensive.
They're not very expensive.
Oh, what is it?
$1,000 each. There's not that much to in the back end, in my view, is the expensive and the intricate part of those. The software behind them that controls them. Hydrogen fueling stations, on the other hand, depends on
So you
your
have a
climate.
tank of hydrogen, you plug it into the car wing, three minutes later you charge.
Right, you're away.
And
You can
the
drive
cost
off.
of the station is not much at all. It's just connecting that tank of hydrogen
It's
to
a
the
lot
car.
more than a charge point.
Okay, but
a
it's
power
still
point,
not as complicated as an electric charging station.
Yes, depends how you're getting your hydrogen there. If you're transporting it in, you have a tank, but your dispenser, that's quite complicated.
Yeah.
And you need your control algorithms as well, your SCADA system that controls it.
Yeah.
Yeah, no, it's a lot more expensive for a hydrogen fueling station than
It
it is
Oh,
for a charge
but it's more
point.
convenient. I mean,
Um,
what commends it? Yeah.
Well, you can charge quick, you can go further. It depends on your sort of local environment, like how far everybody on average needs to travel. You know what I mean?
So I mean, every positive that I can think of on one side is a negative on the other, and every negative is a positive, and so
Not
it sounds like
really.
this is a sort of a draw.
You didn't prepare me for this, Jay. This is a sort of draw. Hydrogen's bonded to everything. There will be so many different ways of producing hydrogen, so each local environment will have a different method of production of hydrogen. And, for, let's say, I think, Mitch Ewan and HNEI and those guys talk to you about the fact that there's a lot of curtailed energy out there. That's a lot more efficient to store that as hydrogen.
Sure, all that curtailed
It's
energy
easier,
can go to
should
the
I
car.
say, to store it as hydrogen.
Well, instead of losing it, because you
Right.
lose it if you.
And big 1-2 megawatt battery banks, you know what I mean? There's a lot
So
of
that's
complexity.
It's
of
how
that.
you see it in the system then.
Right.
It's a
there you go.
macro question.
Right.
Yeah. Okay,
Right.
well, that sounds pretty appealing. But, actually, you're talking about software and all that. If I had an electric charging station, I could get pretty good data on who's doing what, how much they need, right? That whole dream that remember Better Place?
Right.
You're going to have a good memory.
Yeah, I know them. Still got one at work.
Is that right?
Probably
Okay,
have
Better
gonna-
Place. I mean, they had this whole dream of connecting up the car, knowing everything about the car, knowing how much it had, how much it needed, what its condition was in general. I mean, they're going to keep database stats on everything. You can't do that with hydrogen, can you? I
think you can.
Maybe you can.
How much you dispense to the car, you can have your own onboard data logger, better place for a bit glorified in their original business plan to what actually happened, in my view.
Yeah.
You know, as somebody said to me once, you can't get the manufacturers to agree on a standardised wheel nut, so how are you going to get them to agree on a standardised battery,
That's
you know,
true.
with their battery changes? So in my view, that model wasn't going to work. And that is sort of the holy grail, as you say. The back end of the charge points, predominantly for fleet management, be that DoD or large private fleets, how you control that fleet, and also feeding back to the grid. Everybody wants this vehicle to grid, so you can use it as a backup, you can use it to peak shave. You know, if the grid goes down, it's there, you can use it to shave your peak power. But then when somebody needs to use that vehicle, it has to have fuel in it. But hydrogen vehicles are also capable of that. One on the island here, one of the GM fuel cell Equinoxes, that has a 25 kilowatt, you know, inverter in the back.
Mm-hmm.
They take it to shows and, you know, make candy corn and popcorn and those sort of things. So they're both capable of that. It's just that the fuel cell has a long runtime. You know what I mean? When it's
I agree with that. But then I wonder, at the end of the day, you weren't prepared for this question.
You didn't even give me any preparation.
Which one will prevail?
Which one will prevail? Well, in my view, the 2,100, you know, solution is hydrogen, but it will be a combination. It will definitely be a combination.
Well,
they complement each
You
other.
don't think that one will prevail?
If you're driving 15 miles every day, you're not going to go and spend the extra money for a fuel cell vehicle. But if you're driving 200-300, you will.
Let's see Oahu, right here, where we are.
Well, see, there's still studies going on there. It depends what you're producing your hydrogen from. If you're producing it from your coal out at the stage, yeah, I mean your oil,
Yeah,
you
you're
know,
not
your
getting
crude.
anywhere. Yeah.
Right, but if you're using curtailed energy, the hydrogen will be there and available. And there's also, you know, reformation of natural gas, and they're just thinking about bringing gas onto island, and everybody's crunching the numbers on that now. There's a lot of studies going on onto the trade-offs, if you know what I mean, you know, DBED funded.
Who's going to decide?
Who's going to decide? Well, ultimately it'll be these reports to DBED. It'll be policy. It'll be the local government.
Oh.
It'll be policy. These studies will feed into, you know.
Yeah. Okay.
Here at least. That's my view. Yeah.
So I mean, in the case that one does prevail, or it gets, you know, a leg up on things, that where it seems to be that people like that one better for whatever reasons, for the reasons you've articulated, does that mean, you know? I mean, it's just looking into the crystal ball, I will admit that, but does that mean the other one goes away? Or do they sort of coexist? Now you're talking about, for example, an environment like Oahu. Even forget the neighbor islands. Oahu only. Seems to me like hydrogen would be a pretty good bet here. And the question is, assuming it is a good bet here, will electric cars disappear? Will the second, you know, the second possibility actually, you know, continue to exist if everyone runs to the first? I mean, like lemmings?
No. They will coexist, in my view.
Yeah,
Definitely.
so there'll be both.
Depends on your personal requirement.
Salesmanship.
Yeah, and I think, well, I don't know about salesmanship, it'll sell it to yourself. If your, you know, requirement is you don't drive to the North Shore, you know, every day on the weekend, and, you know, you do a lap of the island, well, maybe you'll go with your battery vehicle. And it's going to take quite a while for the fuel cell vehicles to get down to the price point where they compare with battery vehicles.
That's a serious question, isn't it, Cranston? Because they are behind.
Right.
They're behind, you know,
There's a lot more
you tell me there's 16 of them here, you know, and none of them is owned by a personal person like me, or you for that matter. You driving one right now? Outside, do you have one?
No, they won't give me one, disappointing.
Okay.
I used to in Canada when I was at the Fuel Cell Institute.
But I mean, you know, it's like years behind already, and you'll agree with me, won't you, that, you know, that time is critical here. That the one who hits the market first has a huge advantage. Electric cars have hit the market for sure, although they haven't really gone as far as we might have hoped.
True, true.
So the question is, does that advantage, you know, keep them ahead, give them an advantage against hydrogen, or can hydrogen come from behind? And if it can, how long is it going to take?
Well, it's the old chicken and the egg thing, really. And I should just correct one thing. There's actually 26 vehicles on island. There's another 10 internal combustion Ford Escapes. But
Okay,
yeah, 16
right.
fuel
To
cells.
me, that's really the same. Peanuts. Yeah.
Right. On the road. So.
Well, no, you know, I mean, if you have them both here, but one prevails, won't the other one sort of disappear because people are like that? They go for the more popular one. And my last question was, how long is it going to take for us to get to a point where we can say, well, okay, they're really competing now? Because right now they're not
I'm not
competing.
sure they're going
They're
to
not competing.
directly compete, and I don't know how long it's going to take just due to
Well, tell me
the
how long it's
cost.
going to take to put
You
them
know
on
what
the
I mean?
street.
The technology's there, it's just lowering the cost of the components, be that the tank, the balance of plant, and the fuel cell itself. You
Well,
know?
I guess I'm looking for a sort of where the crosshairs meet. And the crosshairs meet is you can buy one. The price is not all that much
Chicken
different.
and the egg, that was what I was going to say, sorry. The chicken and the egg scenario, you know, the manufacturers say that you would need the fueling stations for them to release the numbers, because it comes down to the manufacturing numbers again, you know what I mean? You produce 1,000, they're a lot more expensive than 1,000,000 at a time, but you can't bring the price point down to something that the consumer will accept until you sell 1,000,000, and then, well, you produce 1,000,000, and then you don't have the number of fueling stations to provide the fuel for that 1,000,000 cars. But people like Hyundai, they're coming out next year, no, 2015,
On the mainland.
I think, yeah. They're producing them in South Korea. I
GM.
take 1,000. No, this is Hyundai, you know, the South Korean. GM have sort of, they fueled
Watching
a bit.
and waiting.
Yeah.
A lot of
think
demos, but it doesn't count.
it's nearly a smart move in a way, you know what I mean, to see, I suppose, what other mistakes people make. I don't think anybody really wants to be the first to market. People think they do, but yeah, they
It's
sort of want to be
much risk, much adventure.
Right, and the reputation on the line, you know what I mean?
It fails,
Yeah, they are responsible for the public perception of that technology if they go first.
And
So.
meanwhile, all these car companies, you know, you can say they're putting money into hydrogen research and all that, but where they're really putting money in is gas cars, conventional cars. They're making them beautiful. Not only because the government wants them to do that, you know, for emission control and whatever, mileage and all that, but because they really like doing that, and because people buy those cars. If you walk down into the street here on Merchant Street and said, what would you have today? Most people are going to say they're like an old-fashioned conventional gas car, but today's model with all the gizmos, that's what they would say.
This is true, but in the future, if you say you can put some solar panels on your roof and, you know, you don't ever have to go to the gas station, well, you know, maybe
When
a bit different.
oil goes way high.
$300 a barrel, and then fuel cell industry's laughing. They'll be on the road everywhere.
You'll be a happy guy.
Very happy.
Yeah. So, tell me how it works. You said there was a battery in each car,
Right, yes,
and there's a fuel cell in each car,
yes,
and there's a tank in each car.
right.
So how do they connect up and how do they work?
So you have, sort of, it's a German manufacturer has the, what do you say, the monopoly on how you fuel it. So you put that in, it has check valves that goes into the tank, and you have a standard J2601 that limits the pressure and the temperature that goes in, 700 bar, 10,000 psi, and it typically has a chiller. Nowadays they sort of chill it down to, you know, minus 40. It's a reverse Joule-Thomson. The hydrogen actually heats up when it goes in, so you have to keep it below a certain temperature limit.
Otherwise what?
The tank liner, it's not designed to hit that temperature.
So what happens?
It can peel off the layer. So previously they were using Type 3, which is aluminum lined tank and then carbon fibre wrapped. But now they're going to a Type 4 just to try and lower the cost, and they say in future they want them to shape them to the car. You know, they're a cylinder now.
Oh, sure,
That's
yeah.
inherently, you know,
Either that or shape the car to the
highest
tank.
risk.
Have a square car.
there you go. A round
That'll
car.
sell.
Drag coefficient's 1 of the
Looks like a
70.
tank. So, you know,
Yeah.
what I was getting at was the word blow up.
Oh, here we go.
Right. People are going to ask you that, right? They always ask.
They always do, and they talk about the Hindenburg. A good one that I'm going to start using now, like we sat through our first responder training course with all of the Fed Fire guys.
I was there.
Recently. You were there.
The
There you
HFD,
go.
right? Near the airport, right?
Right.
Yeah.
Cool. I'm glad you went along to that. So they all walked out there stating that it is, you know, safer than gasoline and propane even. You know, it's 14 times lighter than air. It escapes. There's so many safety systems built into it all. You know what I mean? The tanks burst. I think it used to be 3.4 burst pressure, but I think it's down to like 2.2 or whatever. But when
2.2
times it, so if it's at 10,000 psi, it bursts at 22,000. You know what I mean? They shoot them with a 50 cal rifle. They put them on a bonfire and let them blow up. You know, the DOT certification on those things are very high. Then you have your pressure relief valves. You know what I mean? And all the tubing and the fittings. It's a lot safer than gasoline. In my view, it escapes very quickly. If it goes out of pressure relief valves and does ignite, it blows itself out. The big thing is
you don't want to be close to it when that happens, though.
No, you don't.
You know, and one of the things at the fire department training program, which I thought was really, I'm sure you thought it was interesting too, unless this is all boring for you.
The first bit was. The second bit wasn't.
Is that it doesn't you can't see it.
Yeah, it's colourless, odorless, and you can't see it burning.
And that is so interesting. It's almost like a movie with special effects. You know?
Right. It's funny that the carbon is literally the dirty bit. Yeah. Were you there in the afternoon when they lit the car?
I had a special setting so I could take movies
of
the gizmos they were using to identify, see that it was burning, right?
Oh, there you go.
That special gun they had to look at it.
Right, the thermo gun. Yeah. And you can see it, you know what I mean? You can see the heat, the radiation.
If you look through it, it's like a hot road on a summer's day, right?
Right.
It's like
exactly.
wavy air. You can see it.
Yeah, and you will hear it is the thing. You'll hear it squealing if it's... You'll know you've got a hydrogen leak.
Yeah.
A high pressure one. You know
you know that it's burning. And you know that if you get close to it, it'll do something bad to you. It'll fry you immediately.
If you hit one, you can instantly pinpoint.
And I mean that in the nicest possible way.
Right, yeah, there's not much latent heat, so you have to get very close to it before you know it's burning. So
this isn't good. It's never happened, right? Or has it? Somebody got fried.
No, not as far as I know.
Yeah, I haven't heard of it either. So there's this whole, all these government agencies are going to be real cautious about this sort of thing.
Oh, and in all honesty, that's a bit of a bane of us in the industry. We're trying to standardise. We're trying to move forward with standard products, but we have the safety panels and the fire protection engineers, and it's all new to everybody. I think you're talking to Mitch about training the lawyers. We're also bringing fire protection engineers up to speed. You're trying to bring the general public, everybody up to speed at the same time. But I love it. I love the challenge. Love promoting something new to them. You know what I mean?
You just gave me a vision, Cranston. It's a bunch of guys standing around like in the Mercedes ads, with white coats in the laboratory, right? And they all have clipboards, right, making notes about everything. Okay. And what you have is you have the technicians, the engineers on one side. You have the lawyers on the other side. They're making notes too.
Right. Exactly. So true.
Everybody is trying to anticipate.
Right.
So we have the tank, and hopefully the tank is going to be good and get better, and so we don't worry about that sort of thing. And we have all these devices around it, and it doesn't, and it's no waste because it fits in. It's form-fitting into the car.
It will be in future.
So there's no void.
Well, ideally,
there's no void.
Yeah, true.
Okay, so the hydrogen comes out of this thing at some pressure.
Right, so it's regulated. So a bit of a safety feature there is it's regulated inside the tank, so that that's on the end of the tank, so that you don't have any other high pressure outside of the tank, other than that fuel line, and that goes in, and you're sort of done. So yeah, low pressure up to the front of the car where the fuel cell stack sits, and then it goes into the stack, and it separates into an electron and the H plus ion that goes through the membrane.
Go slow on that. So it separates. How does it separate?
So there's a catalyst which is predominantly platinum. They're working on layers and different materials of both the layer and also the material that the membrane that the H plus ion goes through. And it's very... You're splitting the smallest element known to man, so they're very finicky, for the want of a better word. You get a little hot spot or whatever, so you get a little pinhole, throw it out, start the development of the next one. Mm-hmm. Ballard's been developing these since late 70s, maybe 76 or so. They're obviously in the space shuttles, back in the 50s. So there's been a lot of work going into the proton exchange membrane. I suppose that's something worth mentioning.
What's it made of?
It's a Nafion material, it's made by Gore-Tex.
Really?
Yeah.
Like the clothing?
Yeah, I think 3M You know, they're also, you know, materials companies make the membranes, and then there's a bipolar plate, and that has your flow channels in it that the hydrogen flows through. You know, there's
so
a
the
lot
hydrogen flows through. The membrane separates the ions out there.
Yeah, it breaks. It splits off the electrons. And then the H plus ion. The H plus ion wants to go to the oxygen on the other side to form water. It's just, you know, naturally attracted to it.
So it's attracted, and as it's attracted, it's generating electrical current.
Yeah, that's the electron that splits off.
Yeah.
So yeah, H plus ion goes through the membrane, but the electron goes into the bipolar plate and then, you know, out into the circuit.
So it's the bipolar plate that actually sucks up the electricity,
right,
and sends it to a wire somewhere.
Right, exactly.
Okay, and so these things get old?
Contaminants will shorten their life.
In the hydrogen?
Right, I think they're getting up to like, you know, 10,000 hours. I think the Holy Grail, what we're aiming at is 10,000 hours. There's some fuel cells out there that have done that, which is a lot of miles.
If I drive for, say, 2 hours a day, the poor people on the east side, the west side of the island, they drive for 4 hours a day. But if I drive for 2 hours a day, then that's 5,000 trips. And if I go 200 trips, say 250 trips a year, you know, because those are my work days.
Yeah.
You know, some people don't work that hard, but
Right.
250 trips a year into 5,000 hours.
Yeah.
That's a lot.
Yeah.
That's
You should
years.
be fine on the reliability. The key thing about that is it's 99.99% pure hydrogen. So, you know, if you start getting contaminants in there, it degrades the fuel cell, the output, as well as the longevity. And they've done a lot of work here at HNEI up there on Cook Street, that little facility on contaminants.
And Mitch Ewan.
Right.
Yeah. So, and they got a beautiful laboratory. You must be impressed with that.
I'm very impressed.
Yeah.
Yes, we spent some
the hut
time up
within
there.
the hut.
Yes.
A liner within the hut kind of thing. It's amazing.
It is. Great bunch of guys too.
Yeah.
Very, very knowledgeable.
And sitting in the lap of Hawaiian Electric too.
Right, that's ironic.
There's symbolism there.
Right, so very true, yeah.
So if I have to replace this after my 5,000 trips, how do I do that?
That'll be a stack replacement. See, round numbers, you know, DOE just released a report. Sort of a third of the cost is in the storage, a third of the cost is in the balance of plant, and around a third in the stack itself. So
What's a stack?
the stack is the actual membrane electrode assembly. That's the middle bit actually. It's all the bipolar plates. There's a lot of cells, yeah. So all of these MEAs that I was talking about. Let's say, for example, you have 40. And each one's, you know, at 1.2 volts or whatever, you know. You will, they're just an M plate, let's say aluminum, and then they're all squashed together, so you have two bipolar plates, an MEA, and then again and again and again.
So you just switch them out?
Yeah, you switch out that stack.
That stack is...
Yeah, but you still have your air pump and, you know, the balance of plant, they're hoping to get 20,000 hours out of. Yeah, so you can just swap out your stack and leave your balance of plant in there, and your air pump's one thing that'll wear out, but everything else they're hoping to get.
Just for where does a gas engine, a fossil fuel gas engine, how long do those cars last?
In ours, let's say, you know, 200,000 miles. We're doing, you know,
so
200 miles an hour.
I mean, is
they'll
it
last
fair to say
10,000
that a
hours.
hydrogen car isn't going to last as long?
They will in the long run, I think.
But you have to swap things out.
Yeah, but it's the same as internal combustion engine. It depends how well you look after it. Depends if you service it. You know, if you're always using pure hydrogen, you know, if it's purge procedure, if it's always maintained as per the manufacturer's specifications.
I can just see you pull up to the gas station, gas being more loosely defined than it is now.
Right.
And you plug in, and there's 3 grades of hydrogen, right? There's the very fine, the medium.
Oh, no. That's funny, I've never thought that.
Why not? I pay a little more,
no.
and you're kinder to your car, no? You can take it back to the company.
Never thought of it. Yeah, right. One will last like 200 hours, or this one will last 3,000. What do you want? Never really thought about that, but I suppose I should mention, you know, they're doing a lot of work on high temperature fuel cells, or high temperature PEMs, and, you know, I kept talking about fuel cells.
High ambient temperature?
No high operating temperature.
High
You know,
operating
they're sort
temperature.
of about 70, 75, sort of the standard PEM now. But
That's not
I think
very
they're
hot.
that's Celsius. I think they're looking.
Oh, Celsius, sorry.
But it's still not very hot. I think they're looking at, you know, up to 500 or 600 for memory, and that'll help with impurities. Like, I wonder why everybody's doing so much work on this, and that's to help, you know, it lasts longer with impurities in the stream. So there's a lot of people doing work on that. You know, there's not just car companies. A lot of laboratories. There's, you know, national labs. There's a lot of universities doing work on this to try and help out all these little problems. You know what I mean?
Well, a lot of it must be chemistry, as you know, it explains why if you had the chance, you would go into chemistry.
Not if I had the chance, but if you really want to get into fuel cell development, study chemistry. But
Yeah, Rick Rochelle thinks about this in his sleep.
I know he does.
Ask
All the
him
time
any
he lives it, he
question.
breathes
Whoa.
it, he loves it. Spend some time with Rick.
Yeah. Well, okay, so we now have the fuel cell. And, you know, it strikes me the fuel cell is a moving target. In other words, if it takes you 5 years to get to market with a consumer quality car, by the end of 5 years, there's going to be a whole new technology involved in fuel cells anyway, or is there?
Oh,
Or is it stabilized now?
definitely not. Like, every sort of year, there's developments, new things come out. Everyone's sort of surpassing each other.
Yeah.
All the time, and that's another thing as well. I think it was 2009. The fuel cell today from England. They're the old they're part of Johnson Matthey, a big sort of MEA manufacturer of materials. You know, platinum, been playing in the industry some time. They sort of said that it's a year of commercialisation, you know, 2009, because the patents had started dropping off.
Yeah, sure.
But I think there were still, you know, hundreds and hundreds per year, and now they've just gone straight back up. And I asked that question of the DOE review panel recently, and they couldn't give me an answer. There's still a lot of R&D going on, you know what I mean?
Isn't that exciting, though? You know,
That's
it
why I
doesn't
love it.
come to rest. Yeah.
Yeah, exactly. That's
You know,
why.
I mean, ultimately it has to, and this kind of period of excitement, you know, the excitement chapter can only last while the R&D money is available.
Well, that's what I was thinking about then. Exactly. The investors. Sometimes the investors aren't so happy. Yeah, it's sort of that. It keeps going into that valley of death, they call it. But
Right. That's when there's no money.
Right, but there's so many different, you know, applications of fuel cells. I'm just talking about a PEM. We start talking about, you know, motor vehicles, but there's solid oxide
Computers.
fuel cells. There's alkaline fuel cells.
Little ones.
Right. Yes. Replace your battery.
What
in
happened with
everything.
Hoku Scientific? Do you know the story?
No, I don't.
They were doing fuel cells. They had some thing with a Japan company or Korean company, and they were Hitachi comes to mind, I think.
There you go.
And
Right.
they were going to build fuel cells for like laptops. Why not? You know.
Yeah.
And I don't think it happened.
There's a company in Vancouver in Canada there called Anstrom Power, and it was one of the University of Victoria, I think. So professors went out, got 5 million, ended up with 50 million, developed the technology for probably 4 or 5 years, and then, you know, brought out by Bic lighters, of all people. You know what I mean? There's a lot of those sort of companies that have had their technology purchased from. You know, Samsung, I think, are doing a lot of work there. Even the watchmakers are doing a lot of work.
Interesting.
Micro fuel cells, and they're saying now run on butane, you know, lighter fluid. I think there was a company popped up the other day from Italy, maybe. You put the lighter fluid in, you get your battery for your, you know, mobile phone or whatever. There's a pre-release, I think, of just a fuel cell that you sort of break the cartridge, activates it, and then it charges your laptop for like 10 hours or whatever. Yeah, and
It's just amazing, you know. People, we haven't thought in those terms. We think of batteries. There are batteries in our lives, everywhere in our lives.
Right.
And this would change that whole paradigm, wouldn't it?
Right, it's just the consumer wants more energy intensive electronic devices, and in the future the battery won't be able to keep up. That's why they're putting so much
the
money.
battery won't be able to keep up. It's all scary.
There's a limit to
Yeah,
what a sort of
but with
battery
hydrogen,
can
maybe
achieve.
not.
In my view,
In
the battery
with
guys feel
hydrogen,
like
you improve the membrane, you improve the efficiency, you improve the purity. Although and once you get to 100% hydrogen, that's about as
Right.
pure as you're going to get.
True.
And I guess you improve the drivetrain, which I want to talk to you about next. and then you really have some terrific thing working there.
There you go. And yeah, improve efficiency, et cetera, but also lowering the cost. That's the big thing now, pushing the cost down. If you can, simplify the system and make it more efficient, all the better, you know what I mean? But just getting the
Where's the
down.
cost focus now, in the membrane?
A lot of people are because of the platinum, but to me the platinum is not such a massive part of the overall cost. It still needs work. As I say, balance the plant tank, the whole system, all components in the system. Need to be like, even the stainless steel tubing that you use, and the fittings and the valves and the check valves and
All
the leaf
R&D,
valves.
everything R&D.
Yeah, it's all
like
expensive stuff. You know what I mean?
Yes, yes.
A little T thing, like $50 for a fitting, a T fitting, and then you put 4 of those in, then you run a few tubes, a few $100 for a safety valve, check valve, that sort of thing. Interesting you mentioned the drivetrain. That's another reason that batteries and fuel cells are complementary. Anything that improves the drivetrain helps hydrogen guys and the...
But there's a time, there's a in this continuum we've been discussing, from the hydrogen on forward, there's a place where it's the same as electric. Right. It is electric.
It goes into the electric motor. That's it, electric car.
So you're achieving the same net effect on the energy as an electric car would achieve. Right. At some point, it's the same. It's identical to what's going on in the electric car. Am I right?
Right, exactly.
The engine would be the same. Would be the same.
Yeah, it's part of the reason for the batteries. The output of the fuel cell is variable voltage, so you can put that through a DC and straight to a motor. But with transients, ramping up and down the fuel cell wouldn't, last very long if it was doing that. I'm sure they've done work on it, but I think it's sort of unanimously agreed that there'll always at least be some form of battery buffer in a fuel
battery
cell.
Buffer to smooth out the curve, to avoid sine curve kind of effect.
Right, all the transients, everyone's on, off, braking, you want your demand. But yeah, they're after the battery, drivetrain's the same.
But you can have the same kind of technology with the brakes, right? You can hit the brakes, and then it will convert the forward motion in braking back into the battery. Right. The same way as electric cars have them right now today.
Exactly.
Yep. Oh, so some of the technology is already in place then.
Right. Yeah, the Equinoxes here, I know the guys have actually been, playing around with different settings on that, making it more efficient. Something I should put a clause in there, I suppose. There are some, electric vehicles that they want to put the motors on the wheels, the individual wheel. That could be something that happens in future. So you have 4 little electric motors instead of 1.
4-wheel drive.
Yeah, but also the ability to manage and process the torque on each wheel in less than milliseconds.
Oh, that would be great.
Right.
And so it's the distributed model. It's like everything else these days. With the advent of higher levels of technology, you can distribute more at a less expense and have greater local application of whatever you're doing. Ooh, that's exciting.
Yeah, and I think one of the models was British River Simple. They were having a fuel cell, I believe, on each wheel. They just have a little baby fuel cell and a little baby electric motor.
A little one.
Yeah, and then you've got lower centre of gravity. You know what I mean? It's all unsprung weight.
So how do you, if you're developing this kind of thing, how do you take advantage of technology that's already done? In other words, at some point you're hitting the electric car. You're on the electric car's turf. This has already been designed, and you like it very much, and you want to use it for your GM car or whatever you're designing. What do? You call up Nissan or something and say, "Can we use your stuff?"
See, I don't play in that sort of field. As I say, I'm more in the support now, although I've done R&D. Very, very difficult. It's only tier 1s that play in, like, let's say the Quantums of the world, play in that sort of space where they do retrofits, but it's only thereafter the manufacturers. They're only, they're teamed up. It's BMW, and Nissan Renault, I think, and then...
Oh yeah, that was Better Place designed that car, the Nissan Renault, yeah.
Right, Renault was the only car company that went with better place.
That's right. Yeah.
Yeah, in the
Look
first
what happened. Yeah.
instance. Yeah. And it's Ford and Daimler, somebody else they teamed up.
Well, the Germans didn't get involved early on, did they? They're more of a, but they're really involved now. For
Very
sure.
interesting what BMW did. They pushed forward on the internal combustion hydrogen, which is, half the efficiency at minimum, and they went with liquid hydrogen tanks, to increase the energy density. It, liquefies at minus 251, you get a lot greater energy density than you can even 10,000 psi, and they pushed on that with the hydrogen 7, I think it was, and then they finally decided, no, this is not going to work, and then they had to team up with other companies.
They thought they had all this expertise in the combustion engine, so they would just replace I'm just guessing here, the fossil fuel with the hydrogen and see if they could make it work the same.
Right.
Wrong decision.
Right, I've been developing this thing for 100 years. Let's just keep going on this this train. It is a transition technology, as I say. There's 10 on the island, but
Can you buy one like? Oh yeah, you can buy one like that combustion engine.
Not from a manufacturer. Again, a tier 1 supplier will build you. 10 if you like, for however much each. Yeah. If you're the government.
That's so interesting, because you had to get out of the box.
Right,
you could not assume anything, and that's probably still the case today. When you do R&D, you cannot assume anything. No,
you have to, and even some of the research that's out there, so you try and replicate it, so it's not working.
Okay, so now we're into the electric part. Okay. And I take it from our conversation so far that the electric part of this car is pretty much identical to the electric part. I mean, the motor part. Sorry, the motor part is identical to the motor part in a standard electric car.
Right.
Yeah. So your job is done once you've generated the electrical energy by the fuel cell.
There you go.
And I suppose the battery. Is the battery the battery's going to be different, isn't it? The battery you'd find in a hydrogen car, and the battery you'd find in an electric car would be entirely different.
Probably different in size, but probably not different in
Same
technology.
composition, okay.
Yeah, you know what I mean.
Is that a moving target too, or is that being invented while we speak?
A few of the battery companies are struggling a bit now.
Yeah, they are. Extreme, for example.
You're right. There's A123, Valence, I think. I don't think any of them are doing so well.
Why is that?
I'm not sure. It must be just so expensive to develop the batteries, and they've borrowed so much money now they can't get enough sales to justify. I think the government's put a lot of money in there too.
I went on a tour of the switch for Verizon.
Oh,
you know what a switch is? I mean, it's a building.
Right.
With a million switches in it, but they call it the switch.
Interesting. Okay. Right.
And of course they have backup systems, multiple backup systems. Well, one of the backup systems is conventional batteries.
Right.
And it's a room full of batteries, and the battery looks about the size of it's just like a fish tank kind of thing. And when it gets low, what do you think you do? You pour water in there. That's the old, I don't know what you call this level of technology, but it's the old style of battery.
Oh, the first lead acids.
Lead acid. That's their emergency, backup system. It's very interesting.
Right.
But it's reliable.
Well, see, it's one of the early markets for fuel cells is backup power systems. They're very responsive, they'll be up in a second or two, and they don't require any maintenance to sit there, is one of the things. I think there was, I know that there was, of all the backup fuel cells in Hurricane Sandy, all of them started. There wasn't one single failure. And they have a lot longer runtime for the space, for the volume. You can sit a very small fuel cell there and some hydrogen storage. You don't have to maintain it, and it will start and run for longer and give a higher output per volume than batteries. And there's a bit of hydrogen there in the corner at pressure, but it's a lot better to me than lead acid batteries, if you know what I mean.
Oh, yeah.
It's toxic sitting around.
Yeah, right.
And another early market's the forklifts, you know what I mean? I think there's 4,000 out there on the market, so they're running around. There's early markets where the value proposition now adds up. No, it doesn't in the automotive yet, but there's other...
I have another vision, Cranston.
Tell me.
My vision is a huge power plant.
Right.
Silent.
No.
No smoke. No, nothing.
There you go.
It's one great, big, huge combination of fuel cells.
Right. There you go.
Is this possible?
Well, there's fuel cell energy. They're a molten carbonate technology. You know, I think they're out of Southern California. Not sure. Maybe they've got a big project down there. They might be from the East Coast, Connecticut somewhere. But they're already doing 1 megawatt. You know,
With fuel cells.
Yeah. So I think they have a new project somewhere in Europe, 3 or 4 megawatts maybe.
Wow.
So yeah, and they're a sort of tri-generation, which is interesting. You know, they they produce hydrogen, electricity, and heat. You know, 50% of the waste of a fuel cell, the other 50% of the efficiency, well, most of the other 50%, you've obviously got a few mechanical losses in your pumps and the smaller components, but that's waste heat. You can use that, you know what I mean? If you have combined heat and power, like, you know, you replace your boiler, you run it off natural gas, you get electricity for your house, and you get heat for your house. If the cost of those systems come down, it will really take off. But I'm not sure fuel cell energy making much money either. Nobody makes money in this industry
You don't know
yet.
yet.
Well,
like right.
We're still pushing forward.
Still
yeah,
figuring out where it fits.
Right.
So conceivably, this really tickles
From
me.
here to here, exactly.
Yeah,
From batteries to
I could
multi-megawatt power
go
stations.
to, I was going to say Sears, but I won't choose Sears. I'll say Best Buy or
Right.
or Lowe's Hardware or Home Depot
There you
and
go.
buy a little box about yay big, right?
Yeah.
And next to it sits a little thing for a hydrogen container, a tank.
Right.
Okay, I plug it in, and it generates the power for my house.
Yep.
And I am off the grid.
Yes.
I have total control. All I need to do is make sure that I have continuing supply of hydrogen.
And methanol. You can use methanol. There's a methanol mix. It
Yeah.
reforms the methanol.
Yeah.
Yep. So you don't even need pure hydrogen.
And it's, okay, right, and it's like 24/7 because I am not dependent in any way on the sun or the wind or anything. I'm running it just like my own little power plant.
Yes.
Could this be the future? Distributed energy by way of hydrogen?
Yes, for sure.
Now I'll add a feature on this. I have PV on my roof, okay? This creates the hydrogen for me.
It can through your electrolyzer for
And
sure.
it's like a big battery, right? It's like a big battery. I make my tanks and I connect my tanks. In fact, you could probably make it directly with a big tank of hydrogen somewhere in the middle of that.
Low pressure, but very expensive. Like your electrolyzer and your fuel cell and your storage and all your balance of plant and still your battery buffer. Yeah, very, very expensive system, but holy grail. Yeah, that's what we're, you know, sort of targeting at the end of the day. And then you can use it in your fuel cell, you can charge your laptop, you can put it on the back of your camper van. See, that's another early market in Europe, is fuel cells on the back of the camper vans instead of generators. You know, you see all the generators at the food trucks or whatever. Have your little perfectly silent fuel cell sitting on the side of your food truck, you know what I mean? And it ramps up and down. There are a lot, you know, when there's no energy being drawn, when there's no demand for electricity, they idle, they use hardly nothing, unlike a normal generator. Yeah.
Silent and all that. It's fabulous. Okay, now
Yes.
one more question. You know, we're talking about transportation because transportation seems much more obvious than my roof and a hydrolyzer and a tank thing. Transportation, the holy grail in transportation is not cars and buses, it's planes.
Right,
So
I agree.
could hydrogen run a plane?
Well, they already do. The UAVs, a lot of UAVs are now powered by hydrogen. The energy density, I've spent probably, I don't know, 2 years of my career developing full balance of plant fuel cell storage systems for UAVs. It's got a great energy
It's working
density.
today
It's working today. They're out there.
over Afghanistan.
They are around. There are fuel cell powered UAVs, and there's probably a lot more of them than
How
we
does
know.
it work? How does it work? Don't tell them too much.
Same as your car, except you're just spinning a
It's
propeller.
a propeller.
Yeah.
So it's not jet.
Maybe they have jet ones, but I only know of the little propeller ones. So it's just you have your little battery buffer again, and it feeds the same electric motor, and it spins your propeller. And you've just got less weight and greater energy density. You can go further, you can recharge it quicker, etc., etc.
It doesn't. Yeah, and if you're looking at drones and that kind of thing, you
Right.
don't need jet. You don't need high speed. In fact, you want to take nice, clear photographs or whatever you want to do. Whatever you want to do.
Right, exactly.
That's very interesting.
I believe they're on satellites. You know, there's solar panel electrolyzer and your hydrogen on satellites. I believe. I've been told that. I haven't.
Satellites.
Yeah, I haven't ever validated that, but I believe, you know, they use it instead of batteries
So
for energy density on satellites.
There's no boundary here.
There is no boundary, exactly. We can have our little baby tiny batteries in our watches, and then we can have multi-megawatt, you know, power stations.
And hydrogen is completely fungible, transportable, distributable, all the wonderful things in life. Better than batteries by far, and certainly better than gas. I mean, conventional gas.
Right.
So tell me, in the few remaining moments we have, I'd like to know about your career and your day. What do? You do the research? You consult about the research? Are you selling, you know, developments that somebody else? Tell me what you do. I want everybody to, you know, to be envious. I want them to want your job.
A lot of politics involved in what I do. But I prefer to be involved in the technical. I just want to get the job done and, you know, get it out there. We're commissioning a station now up at Schofield. Just the coordination in a way now. We do a lot of proposals. We're looking to get funded for some research and development on
proposals
everything.
for research.
From everything from, you know, storage systems in forklifts, advanced solid state station, you know, systems to, you know, little power generators. Yeah, we're quite diverse in what we do as a company. And
the company specializes in consulting on hydrogen?
Consulting in general, but we have an energy and mobility group that yeah, is based around electric vehicles as well, but predominantly hydrogen, especially here on the island with me, of course.
Of course. Are you the only?
Yeah.
Are you the only person from the company?
No, there's 5 of us here on the island. Yeah, and we've got some very talented young engineers that we're, you know, bringing up to speed. But a lot of their experiences.
How do you hire them? In other words, if one of them came from our audience and approached you for a job, what would you expect from that person?
They're very hard to find. I like the hands-on. You know, all the youth of today are sort of talented with the computer systems where I lack. If they bring that talent and they're hands-on and willing to learn, hard-working and trustworthy, that's the main criteria that we look for.
Boy, sounds so interesting, and not necessarily because right now at this moment, you know, it's a happening thing. It is a happening thing in the prospect. When you sit and think about where it could go, where it probably will go, it will go. I mean, this isn't going to be forgotten. It isn't going to go off the side. This is going to keep on going, don't you think?
Oh, that's what I think. You know, there's doubters out there. You know, it's always going to be the fuel of the future.
Yeah.
But as I say, there's places where the value proposition is there now, and it will only expand from that. There's only going to be more sales, and there's a worry that some companies won't survive, but the overall technology, the concept will.
Yeah,
I firmly believe
you will have a fantastic career. I mean, you're already, but you're going to be involved in a career that can only expand in great multiples. And someday, you know, you'll have a technology company of your own. I know you will, and it'll be in hydrogen, and it'll be global. Watch me. You can, let me know this happened, and if you'll still talk to me then.
Of course, I'll come back. I'll look forward to it.
So tell me about Hawaii now. Where's this fit in Hawaii? You're here in Hawaii for a reason. Hawaii has a special quality for you.
Love to surf, obviously. I'm from Tasmania, a long way south. We have some good waves. It's a lot warmer here. It was coincidence. Was doing work with a professor here. Came over here, sort of sight unseen. And that's sort of, long story, what happened with that technology and that particular professor. But then met the owner of the company that I work for now. He had an office in the same building and got to know him quite well. And he's like, come with me, and haven't looked back. I love it. I love it here. It's a special place for me.
You'd like to stay as long as you could?
Ideally 6 months, 6 months. I'd like to sort of do projects in Australia
and
do projects here as well. Miss the family, you know what I mean. A light shout out to family. But it'll always have a place in our heart, Hawaii. We landed here for some reason, you know what I mean, by coincidence. What
about Hawaii itself? What does Hawaii offer a special place for the research? Does Hawaii offer a special place, does Hawaii have a future in hydrogen more, say, than other places?
I think so, definitely. A, the curtailed renewable energy, B, the DoD presence here and the fact that they will require more and more hydrogen, the energy independence, and people like HNEI, Rick Rocheleau and those guys, and the fuel cell facility there on Cook Street, they're all extremely talented. They're into it. It's slow getting things going with the government, but once you get a bit of momentum, I think we can do great things, and we can get out there to the public. It's a small community. It'll be more accepted by the public. You're not trying to introduce a stranger every time because you see everybody every 3 weeks or whatever.
It's true.
What I mean? I'll run into 5 people when I walk down the street with my car.
That's the advantage, but it's also the disadvantage, if you will.
And in a way, that is very true. If they could get over that little political thing, we could all just join together and agree on that common goal that's better for us all.
Yeah.
I think we can definitely get there.
Thank you, Cranston.
Thank you
Great
very
to
much,
talk to you.
John.
Hope you don't
Very
mind my
enjoyable.
sharp questions.
No, I like the no preparation thing.
It's
Hope you
been
call me
fun.
out. Someone will call me out on one of my statements, I'm sure. But it
Thanks
has
very
been
much.
very much a
Talk to you
pleasure.
again soon.
Yeah, thank you, Jay.
Aloha.
Aloha to you too. Cheers. That was fun. Put me on the spot.
Well, he called me out for putting him on the spot. Did you turn it off?
Yes,
Oh, I don't.
I just thought it's a hi.
Hi.
Nice to meet you.
Nice to finally meet you. How's it going?
I can't wait.
Thank you very much. No worries, no worries.
Did you have fun?
That was fun. Cool.
Jay Fidell is amazing. He's an amazing host.
I don't even know what I said now. People are going to be like,
That was all good.
I hope so.
Did he ask you difficult questions?
A few here and there. Yeah.
Ooh.
Yeah, no, it was fine. I'm sure I've been asked.
Chris can handle anything.
We should have a glass of water.
Yes, of course.
No worries. No, that was heaps of fun. Thank you for that. Wouldn't like it. It would be perfect for that.
You have Jay's.
Yeah, I grabbed one of those. Thank you very much. Yeah, so what that was.
Let me get mine.
No worries.
Did you sign